This is the first part of a lecture on absolute values. We're going to focus on the concept of absolute value here. And I'm going to be very broad in my discussion about absolute values because I think that textbooks tend to treat absolute values in a very piecemeal fashion. So you'll understand what I mean when we get into the concept here. Prerequisites for this specific lecture, you must know what a number line is, and you should be pretty familiar about calculating distances and be familiar with graphs, at least the coordinate plane, the Cartesian coordinate plane. We'll start with a basic conceptual definition, which is not exactly 100% correct, as most conceptual definitions are. They tend to all be a little bit flawed. The size of a quantity is called the absolute value of that quantity. So in reality, when you hear the words absolute value, you should also think size, magnitude, modulus. That's kind of a unique one. Modulus is what some people use to refer to the size of a number. But oddly enough, to get a little more technical, we could also think of it as its distance from zero. These all mean the same thing. So when somebody says what's the absolute value of 3, they're really asking you what is the size or the magnitude of 3, or how far away from 0 is 3. The answer to all those questions is just 3. By the way, the notation that I've just written down with the vertical bars, the two vertical bars, is the absolute value notation. Essentially, you're just saying what is the size of whatever's in there. And this notation is used all throughout mathematics. So if you go on further into trigonometry and into calculus and into linear algebra and stuff like that, you see these absolute value bars are used for something called the determinant. You can also see them for use with determining the magnitude of a vector. It all means the same thing. How big is this object? So the most important thing to take away is that the absolute value of something is really that object's distance from 0, if there's one object in there. If there are two objects in there, well, let's discuss that. And I suppose before we discuss that, maybe I should just do a little more conceptual stuff here. So let's say the absolute value of this number right there, the absolute value of a -7. The idea is to draw a number line. That's a pretty good number line right there. Mark out 0 on it, and then mark out the number that you're concerned with, and the number that you're taking the absolute value of is -7. Now remember, the absolute value is really asking how big is that number, or in other words, how far away from 0 is that number. And whenever you're talking distances, distances are always positive. So this is 7 units away from 0. So therefore, the absolute value of a -7 is 7. It's because it's 7 units from 0. Now here's an odd notation, but it's still kind of valid. What is the size of that point? That's a point on the on the Cartesian coordinate plane here. So let me just plot it out. And we want to know the size of that number. In other words, how far is it away from 0, or in other words, the origin. Well, let me zoom in on that. So I've zoomed in over here. Here's my point, 1, 1 right there, which means that I've gone over 1 and up 1 unit. And the distance from the origin to that point can be found using the Pythagorean theorem, right? So this is more advanced, but the fact is you can still find the distance between 0, which is the origin on the Cartesian coordinate plane, and your number, or in this case your point. It would be the square root of the x value squared plus the y value squared, or in other words, root 2, because it's Pythagorean theorem. So I guess the magnitude of that point would be the square root of 2. That's the size of that point. Now, honestly, a lot of mathematicians will argue with me on this and say, wait a second, you can't have the size of a point. But later on in mathematics, you find out that you can have a size of something basically like a point. So I'll deal with the wind blowing from mathematicians about that. And the reason why is because I want to impart to you right now that these Vertical bars basically are just saying how big is this item? How far away from 0 is it? But that brings up a pretty good point, because it's not necessarily true that it's always just the distance from 0. Well, actually it is necessarily true that it's the distance from 0. But there might be a subtle difference in interpretation if we have two different objects in there, like a 4 minus 3 or something like that. Well, if you know how to add or subtract here, you know that's going to be the absolute value of 1. So this 4 minus 3 in the absolute value bars is just saying what's the distance between 1 and 0, which we know is going to be 1. But this also gives you a clue, possibly, if I draw out a number line here, maybe this will make sense. It might give you a clue as to these two numbers themselves, 4 and 3. So if I plot 4 and I plot 3 on a number line, it's pretty easy to see that the distance between them is just 1. In fact, if I had said, what's the absolute value of 3 minus 4? Still, again, the two numbers that I'm really concerned with are 3 and 4. And the distance between them is still 1. So it turns out that the absolute value bars measure two things. If you have one object in there, it's just this distance from 0. If you have two objects in there, it's the distance between those two objects. For this, we just write up a new definition, or a new conceptual definition of absolute value. Turns out the absolute value of a minus b is the distance between a and b. And this actually doesn't break the rules that we know for absolute value, because, for example, the absolute value of a negative 3 is the same thing as writing the absolute value of a negative 3 minus 0. In other words, it's the distance between negative 3 and 0, which we know to be 3. So it turns out that this definition is actually the best definition for absolute value that we possibly can have. And it's the best conceptual definition. There's actually some very nice mathematical definitions, but this is really the one that I would prefer that most people remember, that the absolute value is just the distance between two numbers. And if you only have one number there, then it's the distance between that number and 0. And just to finish out here, we could always take something like the absolute value of 7 plus 8. Well, what does this mean? Because there's a plus there, not a minus. Well, that's the distance between 7 and a negative 8. That really is what that means. You have to manipulate this to get a negative in there, but it's the distance between 7 and negative 8. And if you just bring up a number line really quickly and you plot negative 8 and 7 on there, and here's 0 partway in between, I know the total distance between those two is going to be 7 plus 8, or 15. So this distance is 15. Obviously, you could have just done the math. It's a little bit easier in this case, or a lot easier actually, but it's still a good way to kind of view the conceptual definition, that it's a number minus a number.